Okay, boys and girls, please look at the sheet I just gave to you. And if you please look at this side, it says exponential and logarithmic function notes. This set of notes is going to be pretty important to you. I want you to keep this out with you throughout the entire chapter that we go through. You'll see a lot of logarithm pieces here that you guys did last year. I know you went at them at a pretty slow pace. You didn't cover a whole lot of the material, but logarithms tend to be fairly confusing for people. We will make it as easy and simplistic as possible. But we want to deal with exponential logarithmic functions, and today we want to look at really parent functions. But these are formulas that, just like this past time, you're allowed to have a little note card. You're probably going to want to write some of these down on the note card as well. So that's just something to keep in mind. The back side we will do, I thought about giving you 2 pages, but I wanted to save paper. So we start, please take out your graphing calculator, and we're going to plug in some values for that. The first type of exponential function that we want to look at, and what makes something exponential, if you look at this first part here, it says y equals a to the x. You guys are used to seeing x sitting in the base, and then the exponent would be, say, 2, 3, or 4. Well, that's different. Right now, a will be the base, and then the exponent is the variable that changes, and this generates an interesting looking graph. We want to look at a values that are greater than 1. So, for example, we want to look at, say, 2 to the x power, or 4 to the x power, or, say, 7 to the x power. Let's type in those 3, and then I want you guys to be able to identify in what ways are they similar and in what ways are they different. What ways are they similar? What ways are they different? Everybody got punched in? Okay, we'll give you guys a couple more seconds. We are going to, we'll zoom standard when we view it, zoom 6, so that we all have the same viewing window. So we got 2 to the x, 4 to the x, and 7 to the x. We go zoom 6 for zoom standard, and as you look at this, there's 2 to the x, there's 4 to the x, and there's 7 to the x. What point do they all pass through? Can you see that? What point do they all pass through right there? They all pass through the point 0, 1. Why is that the case? Why do they all go through 0, 1? Let's think about it. This coordinate is 0, 1. 0 is the x coordinate. 1 is the y coordinate. So what it's saying is that 1 is equal to, better. Close. If you take anything to the 0 power, it's always equal to 1. So by definition, if anything is raised to the 0 power, it's equal to 1. If you don't know why that's the case, let me show you real quick. If you take x squared and divide it by x squared, that'll be x to what power? X to the 0 power, right? Because you subtract the exponents. But you guys know also if you take a number and divide it by itself that you get 1. So therefore, x to the 0 power, anything to the 0 power is 1. So all these graphs travel through 0, 1. And so you can see this piece right here. You can see how they go. If you raise the a value, obviously it's a steeper graph. Let's look at if a is between 0 and 1. So a could be, say, 0.5 or 0.9 or things like that. So let's go back into y equals, and we'll go, say, 0.9 to the x. We'll go 0.5 to the x. We'll go 0.2 to the x. We'll look at those 3, and we'll see how it possibly looks similar and different from what we just did. We We press graph. That's 0.9 to the x. That's 0.5 to the x. And that's 0.2 to the x. How do they look similar? They all pass through that same spot, because if we take it to the 0 power, we get 1. But they're over on the other side, aren't they? Yeah. So if it's between 0 and 1, the graph, the general form is like that. And again, it passes through 0, 1. So you need to be familiar with these shapes of graphs. True or false? These have an asymptote. True. What's the asymptote? X equals 0. I'm sorry, y equals 0. This horizontal line, it never crosses that x-axis. Okay? Y equals e to the x. One thing you guys did not talk about last year would be natural logarithms. With natural logarithms, we come up with a base of e. E is a very interesting number. It comes up a lot within models of growth and decay. We use it a lot in the applied sciences, like chemistry, physics, things like that. Just like pi is the number 3.14, yada, 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 e has a number to it that repeats. It goes 2.718, so on and so forth. So the base is 2.718. So when you say e, that's not a variable, that's a number. Now, if I have y equals 2.71 to the x power, will that look like my first graph or my second graph? First graph, because e is greater than 1. So if you have y equals e to the x, it looks like that. And y equals e to the negative x, I'm going to play a little trick on you here, and hopefully it won't confuse you, but watch what I'm going to do. Instead of writing it as e to the negative x, I'm going to write it as 1 over e to the positive x. Can you see how I can do that? If I take a negative exponent, that means that I flip it upside down. So I just flipped it upside down to remove my negative exponent. Will 1 over e be greater than 1 or less than 1? Less than 1. So that graph will look like this. And that's the model for growth and decay. You'll see exponential functions all the time. If you were to look at our national debt, that would be an exponential function. If you were to look at the rate at which bacteria grows on your kitchen counter when you haven't washed it for a while, that would be an exponential function. If you looked at the rate at which rabbits produce during the summer, that would be an exponential function. If you looked at radioactive decay, material that decays over time, that as well would be an exponential function. So, can you memorize these shapes? Not too hard? Okay, we flip to the other side. We try some harder problems. These are the notes that I want to take today. The back side is a sheet that you will keep. Obviously, you keep the front side as well, but I just want to save paper. But that back side is very important to you over the course of the next month, okay? We will not get a test in before break, but we'll have a test shortly after break. I promise you we'll review accordingly. It says sketch a graph of the following functions. Y equals 4 to the x. Give me one point that it passes through. 0, 1. Okay? And then if you're ever wondering, you can find another point that it passes through. For example, if I plug in 1 for x, what do I get for y? 4. If I plug in 2 in for x, what do I get for y? 16. Let's try a negative number. What if I plug in negative 3? Anybody know what 4 to the negative 3 power is? 1 over 4 cubed, or 1/64. So if you just think about it, you don't have to plot all these points, but if I plugged in, say, a negative 3, I would have a value very close to 0. If I plugged in a positive 1, I would have a value of 4. 2, I would have 16. So this is the shape the graph makes. All I want you guys to do is draw the shape and just label one point on it other than 0, 1. I'll show you what I mean in this next graph. Question? These are points that are on that graph. Oh, when I plotted them? Yeah, so I just plotted those points. I didn't plot 216. I didn't plot that point. But I did plot these others. And I will just do that, Whitney, for the first one. I won't do that for any more. Letter B. How will that graph look different from the first? Opposite way. So I still pass through 0, 1. Always. Well, almost always. We'll look at an example where that doesn't happen, but almost always. So if they're of that normal form, then we do pass through there all the time. Now, I'm just going to label 1 point, okay? I'm just going to plug in 1 point. What would you like to plug in for x? You guys pick something. 1. So if we plug in 1 for x, we would get 1/4 for y. If you plug in 2 for x, you get 1/16 for y. So all I'm going to do is, this is just what I want you to do on your assignment, so you understand that you can plug in points. Just pick a spot and label it. It doesn't even have to be accurate. Just pick a spot and label it. 2 and 1/16. Okay? Great. It tells me you understand that you can plug it in and generate a value. Okay? C, y equals 2 to the x. Which graph is that going to look like, A or B? It'll look like A. So I'm just going to draw that shape. What would you like to plug in for x? 2. Great. So 2, 4. So 2, 4 is a point on that graph. That's all I'm doing. Let's try some harder problems. These are pretty easy so far for you guys. D says y equals -8 to the x. You tell me this. Is the negative being taken to the x power? Or is just the 8 being taken to the x power? Just the 8. So what's the negative going to do to the graph? Any ideas? It will flip it over the x-axis. So I'll draw the first graph. This is what it normally looks like, right? So instead of passing through 0, 1, it will pass through 0, -1. It will be flipped over. So the blue graph is the actual way that it's supposed to look. Okay? And I will plug 1 point in on there. What would you like to plug in for x? We'll plug in 2. What's 8 squared? And 64, very good. Then you make it negative, so -64. So 2, -64 is a point on that graph. And again, it does pass through 0, -1. Again, the red graph would be kind of the parent function, so to speak. You don't have to graph that. The blue one's the actual graph we're looking for. Any questions on that? Let's look at another transformation. Y equals 3 to the x minus 4. I subtract 4. What's that going to do to the graph if I subtract 4? Shift the entire thing down 4 units. So instead of having an asymptote at y equals 0, I will have a horizontal asymptote at y equals -4. So there's my horizontal asymptote. And instead of passing through 0, 1, does anybody know where this will pass through now? 0, -3, 4 units down. So that's where this is going to pass through. You can go ahead and put a point on there. If we were to plug in 2 for x, 3 squared is 9, minus 4 is, so the point 25 is on that graph. And notice I'm not being careful where I really plot the points. I'm just trying to get them in the correct quadrant. This point right here, well, it normally goes through 1, right? But the whole graph is shifted down 4 units. So 1 minus 4 will bring me to -3. Does that make sense? Okay. And then the last one. The last one's a little bit more confusing. I'm going to draw just the general parent function to begin with. I have 2/3 to an x power. What will 2/3 look like? That would look something like this, right? Okay, so that's what I want to think about in my mind. Now, what does the x minus 2 do to it? 2 units to the right. Okay, this will be a horizontal shift 2 units to the right. What will the +1 do? Then up 1. So you can see that this point 0, 1 will move 2 units to the right and then up 1 unit. So it will be located then at 2, 2. So that's the real point I go through. How about my asymptote? It will be moved up how many units? Up 1 unit. 1 unit. So you just want to be able to practice generating those graphs and moving them back and forth. Any questions on that so far? We've seen things like that before, haven't we? I mean, I've had you graph transformations before plenty, right? Same type of stuff. Okay, let's try example 2, 4 problems. These are actually easier than the ones we just did. It says find the exponential function that passes through the following points. So we're looking for y equals a to the x. Now you don't have to draw it, but I'm going to. They do give you a graph in your book. And it passes through 0, 1, and then 2, 25. So somewhere way up there. Okay, so the graph goes something like that. Well, let's think about it, okay? First of all, is a going to be greater than 1 or less than 1? It'll be greater than 1. And I'm going to use this point 225. 2 is the x value, 25 is the y value. So 25 equals some number a to the second power. What would a be? A is 5. So what's the equation for my function? Y equals 5 to the x power. Then I go to the second piece, 0, 1, and negative 1, 2/3. If I plot this to try to get an idea of what it looks like, 0, 1, and then negative 1, 2/3, that'll be slightly lower. Looks like the graph is going something like that. Is a going to be greater than 1 or less than 1? Greater than 1. As long as it has that shape, a is greater than 1. Okay? Now, let's try to come up with a value. I know it has to be of the form y equals a to the x. It says y is 2/3 equals a to the negative 1 power. What number do you take to the negative 1 power to get 2/3? What does it mean to take something to the negative 1 power? You flip it. So what number did we flip to get 2/3? 3/2. So 3/2 is equal to a. So y is equal to 3/2 in parentheses to the x power. Let's try C. 0, 1, and 3/8. So somewhere up there. Will a be greater than 1 or less than 1? Greater than 1 still. We're looking for y equals a to the x. We have a y value of 8. We have an a value that we're looking for. We know x is 3. What number do you take to the third power to get 8? A is equal to 2. So your equation should be y is equal to 2 to the x power. That would be that graph. Any questions on 1, 2, or 3 before we move to the last one? Okay, our final problem, we have 0, 1 is a point, and 4 and 1/10,000 is another point. Oh boy. 0, 1, and then 4 and 1/10,000. So 1, 2, 3, 4, 1/10,000. That's going to be really small there. Looks like my graph goes something like that. Is a going to be greater than 1 or less than 1? It will be less than 1 now because the graph goes the other way. So that means our a value is smaller than 1. So let's try to figure out what our a value is. We're looking for y equals a to the x, and we know 1/10,000 is the y value is equal to some number x, or some number a to the 4th power. Do you know what number you take to the 4th power to get 1/10,000? Not 10, but 1/10. 1/10. So A is equal to 1/10. So my equation is y equals 1/10 to the x power. Now, somebody first hour said, well, Mr. Gens, could we write that differently? Could, instead of writing y equals 1/10 to the x power, could we please write it as y equals 10 to the negative x? Those are the same things. These are identical. I don't care which way you write it. You do what you want. Okay? Any questions? Can you do this? Tyler says, bring it on. Very well. I will. There's your assignment. You have the rest of the hour to work. Some people had half your time to work first hour, and they finished the whole assignment yet. So please get to work on that. Your assignment from yesterday, I don't want to see it. You hold on to it. I don't need it. I will give you all credit for doing it.